Right, just send an email to everyone. There are some changes to the schedule. It's actually good news because I delayed the due day for homework 6 to next Thursday, not this Thursday, because we have a midterm exam next Tuesday. So I want to give you guys some time to prepare for it. I think it's taking 30% of the whole grade or something. I forgot, but it's definitely more significant compared to the regular homework assignments. And so midterm exam on next Tuesday, and followed by no lecture on Thursday. So you'll keep working on homework 6 because it's due after. No, sorry. So midterm on Tuesday, and then Thursday will be a lecture. UArt, serial ports, pretty interesting. And then spring break, and I'll give you another week after spring break to work on the UArt, and still April the 5th, and then followed by 3 new tutorials. And I'm thinking about a course project for you guys, so I will be, try to be creative to combine some of the things you have learned in the semester to a larger scale project in the end of the semester. Okay. So, want to let you know what are going to be on the midterm exam. So first, for the data types, you want to know these fixed point representation formats like UQ 16.16. This is pretty straightforward. And also keep in mind that the exam is open book, open notes, open internet, right? And floating point representation here for either both positive numbers and negative numbers as well. And addition and subtraction for floating point representation. So I'm doing a midterm exam review. If you are late, make sure you watch the video afterwards. All right, don't miss any points for the exam. And so data types, definitely review it. And there's a very simple problem for VGA, just asking you some of the parameters over here, it's very simple, and it's open internet, so you can always come back. But the bottom line is just need to understand what I'm asking. Another one, very important. I mean, if you are attending a digital design interview, I'm pretty sure they'll ask this question to you guys. Blocking and non-blocking assignment. So I don't think I explained that very extensively when we were doing this tutorial. So now let's take a look at it. So first, what is blocking and non-blocking? How do you understand it? So which symbol is for blocking and which symbol is for non-blocking? Definitely don't confuse with these two symbols, right? Why is this called blocking? These are just the concepts, right? But if we are looking at this example, we know that if you are doing blocking assignment in here, just execute it for once. What's going to be in Y2? So all these, so the blocking assignments, you can understand, try to understand them as wires. So if you only execute this once, X will be passed to Y2. So Y is called blocking assignment. Because every line, it waits for the first one, for the one above to be finished first, and then do the next one. Why is that? Because the next one, the value here is dependent it depends on the assignment over here. So x is being assigned to y0, and y0 is going to carry the new x over here and then assign that value to y1. And this assignment depends on here because y1 is being updated. So y1 will be here and then eventually assign everything to y2. So every single line depends on the one above. And whenever, before it executes the second one, the first one has to be executed first, and it's blocking the execution of the following one. That's why it's called blocking assignment. Does that make sense? But here it's a non-blocking, which means the old values here, here, here are being assigned to the left-hand side, to these variables. It's not blocking any assignment. When it's executing the first one, the second one is not being blocked. It's non-blocking. It's not being blocked. So it's sending the old values to here. So they are being executed at the same time. So for the first one, after it's being executed for once, y2 is going to hold the value of x. And so y0, y1, y2 eventually will be x in all of them. But for here, for the non-blocking assignment, y3 would be x, and y4 would be the old value of y3, and y5 would be the old value of y4. That's how that works. It's going to interview question everywhere if you're interviewing with a digital design company, which is very popular. There are so many on the market. All right, so basics, definitely you want to go over it because all these Verilog problems on the exam, would be based on these fundamental things over here. And another one, I think it's not in here, it's in the lab. Is it here? No? Here? How to make a mux? How to make an adder? Okay, you need to know that. And do you understand what's going on here? So if S1 is 1, it's going to do this. If S1 is 0, it's going to do this. And there's an embedded conditional statement inside the other one. So if S1 is 1, and if S0 is 1, it's going to pick up D3. If S1 is 1, if S0 is 0, it's going to pick up D2. Okay. Make sure you know how to make a 4 to 1 mux, 3 to 1 mux, 5 to 1 mux, for different versions of mux. Use this conditional statement over here to execute, to implement the mux design. And for simulation, if I'm asking you to generate a clock with an arbitrary frequency, just in simulation are able to do that. For example, I'm saying like create a 10 kHz clock. I mean, things like that. And another one, I think is over here. Parity generators, checkers. And what's the logic for parity generator? If I give you an 8-bit binary number, what's the logic you can use to directly find out if you have an odd number of ones in there or even number of ones in there? So what's the logic? It's very simple, right? It's just one logic operation. Let's just review this part of the tutorial. It's an XOR, right? Just XOR all the single bits in there, so you can find out if it's 1, then you have an odd number of ones in there. If the result is 0, then you have an even number of ones in the binary number. And the last one would be the sequential circuit. So it can start from the sequential circuit like this, let you implement it in Verilog, or it can be a state diagram and convert into Verilog to implement it. There's no synthesis, no implementation, because it takes so long. And it varies, depends on your computer. Everyone, so it's not fair. It's just a simulation. So create a Verilog module based on the diagram, state diagram, and design the test bench, things like this, right? So this is not perfect, but you just want to verify as many logic, as many routes as you can. This one didn't verify every route, but looking at here, so all the highlighted ones are being verified, but these ones are missed. So you don't have to find out a way to verify all the transitions, but definitely you need to try to verify as many as you can, right? And then show the result over here to label the transitions. When the X is 1, it's going to change to another state. Just label it. So that's the last problem. You got 10 problems on the exam. 85 minutes during the lecture time. So you are not going to put everything on a website, right? So you do the simulation, do the snapshots, and copy and paste the pictures into a Word documentation with all the descriptions and explanations of your answer, your solution, and eventually convert into PDF and send it to me by email, right? Before the end of the class. Any questions regarding the? No? So today's plan is to let you work on the VGA tutorial. And also on Thursday as well, if you have time, you can also start working on the lab. Let's see, when is the lab due? Is it the first week or second week for the lab? Start the second week. Right? So you are supposed to finish it before Wednesday next week. So I didn't provide too much information over here. I just provided the tutorial. I think it should be adequate. I don't know, but if you feel free to ask any questions if you have. It's a little bit complicated. It takes a lot of time. That's why I'm thinking about the lab is due next week, and also you got a VGA tutorial. So that's why I postponed that to Thursday next week for the VGA tutorial. Hopefully this will help a little bit. And so we'll do the midterm exam over here, right? In this classroom. No other questions?